Hello and welcome to the first video for Bioinformagic, where I have been asked to answer some bioinformatics questions on how-tos, showing how it's done, implementations, and explanations. To start off with, most people will likely be using some sort of Linux or Mac OS desktop. However, I also know that I have quite a few people that use a Windows desktop or Windows laptop, or potentially even going with something like a tablet or laptop that might be Windows based. In order to make a lot of the things work that we're going to talk about as we go through a lot of these videos, you will need something Linux based. Now, previously, that might have been a difficult challenge because for a lot of Windows users, what you would have to do is essentially get a second hard drive, dual boot, and have a boot option when you load your computer to switch between Windows and Linux. Thankfully, the good people at Microsoft have wised up a bit and realized that this is something that a lot of people do and that there are a lot of things that only run on Linux, especially in a corporate environment and specifically in science. So, if you've gotten this far and you're saying, well, how do I do this? Then I'll link a video in the description. It'll explain to you how to change the settings on Windows so that you can install Ubuntu or Linux directly into Windows 10 or 11. That way you don't have to buy a new hard drive. The path will be a little bit weird, but we'll talk about that as we go through. If you've already done that and followed the video that's linked in the description, then you've already changed your settings and it'll allow you to add an app. So if we go in here and we go to Ubuntu, you'll see that I already have mine installed. However, if you don't, you can always go to your Windows store and then you can just search for Ubuntu. Assuming you spell it right, you'll see that there's an app. There's also different versions of Ubuntu, and you can choose whichever one tickles your fancy. For most people, you could probably just select the basic app, but if you have specific needs, then you can go ahead and choose one. Especially if you choose the latest one, it never hurts. Now, if you've done all that, you should see Ubuntu show up in your taskbar. And you can see I have different ones in here. We'll go with the basic one. So now you have a Linux essentially terminal that you can use within your own Windows framework without having to install anything. That's step one. What I'm going to cover probably within these first videos and that is mostly, I guess, rules of engagement and ways to set yourself up for success going through bioinformatics. When you're doing a lot of bioinformatics work, there's a lot of discussion around making things reproducible. So some of the things we're going to talk about in the beginning are going to be essentially conda, which is allowing for package managers, but also exporting the environments that you can give it to other people. After that, we will show how to use Docker, and with Docker, you'll also see that you can use a conda environment to build your Docker container, which we will then integrate into a Nextflow pipeline to show you full circle how you can go from developing your own scripts if you want, or including software, and doing it in an easy way that will manage all of your packages and dependencies while making your software reproducible. And therefore also your analysis will be then reproducible. And if you're in an academic setting, that means you can pass it on to your collaborators. If you're in a professional setting, say biotech, then that means you can pass it on to your customers. And you only have to do it once and you can maintain it a lot easier. So I don't think I've installed Conda yet, which is great. And so we're going to go and download it. I actually think it's on my other one. I'll link to where you can download it. I won't necessarily go through the whole thing because it's essentially just a bash script. However, with that, let me go ahead and open my other one. Clear. Right, and so this is just me downloading the installer. Now we can see, hey, we got it. It's great. And then I'm going to run. It makes you go through the whole thing. We agree. And then that's fine. You can unload it there. And then I'm just going to go with yes, because now when I start it up for the future videos, it will have it. I have to probably do reboot. Start, or I guess in this case, I can just open a new tab. Oh, unfortunately, this decided it was going to open PowerShell. So what I need to do is actually go here, say Ubuntu. Why that color is? Oh, this is actually something else. Okay. Okay, now that we have our conda installed, I think if I do this, sorry, it needs to be list. We can see that there's nothing in this, which is great. Essentially, when making a conda environment, realistically, what I like to do is each one of my scripts or modules or something that any sort of analysis I'm doing, I try to make a different environment to avoid any sort of conflicts. So for instance, in this one, we can just do, let's say, some basic Python. So I'm going to do conda create, and then I'm going to do -n for the name, and let's just call it Bioinformatics, call it Bioinformagic, Python. And it helps if you spell things right. Accept. Okay, and now you can see here it gives me some stuff, and normally I don't name things this weirdly because it's kind of annoying. However, you can see here it says base. Now, in order to use my new environment that I created, which has nothing in it at the moment, I'm going to copy this. Anytime you do any sort of activation, deactivation, so I can essentially do the same thing if I do conda deactivate Bioinformagic Python, and I guess it's just Python. It's just kind of deactivate and goes back to base. So along with that, so now I can activate and deactivate it. And what that means is now I have separate virtual environments. Each one is going to have its own separate package management, which is great. So now if I do conda, and actually in this case, I can just hit the up arrow to go to where I activated it, which unfortunately is not there. So we're going to just copy this again. All right, and you can see again, this changes here. It tells me which environment I'm in, so I won't be confused with my virtual environment. And let's just clean this up a little bit. And so if I do Python, it's going to say none of this is found. Okay, so what do I do? Well, I'm going to open up my Chrome browser and we're going to go to Anaconda. And from Anaconda, you can go in here. Actually, I want to go to conda. Here we go. Package repository. So this is the one you want. anaconda.org/condaforge/repo. There are other repos in here, but in our case, I'm going to go get us some Python. Why Python, you ask? It's a general usage language that's heavily used both for bioinformatics and data science. You can see that there's whole lots of these. So if you go into labels, you can see all the different versions in case you want something specific. The main one right now is actually 3.14, which is the newest version. You might need older versions depending on what you're trying to install, but if you install it from Conda, it will fix them for you. And I can kind of show that in a way here. So let's just go back this way, and if I just do conda install Python, it'll say like, okay, I need to install all these things into your environment. You can see that it asks you first if you yes or no. I'm going to say yes because we want Python. And now, as you saw before, when I did Python, it said I can't find this package. But now if I type in Python, I now get Python 3.17 and voila. Now, this is great because also if I do a pip install with the Python that's in this virtual environment, it will also store those packages and the pips that the packages that were installed with pip in the environment file as well. So in case you're wondering how that works, I could do, and actually I'll do this first. If I do conda export env, I think it might have to deactivate first. Conda deactivate. I have to do conda export env base, and I say let's double check in case you're ever wondering. Yeah, so I don't have to say, it's just gonna be whatever the current environment is. And you can see this is everything that's in my base environment. You can also see that it has my whole thing there. If I go up here, there should be a conda activate. Of course not. We're not that lucky. Conda activate Bioinformagic dash Python. So I did not spell activate correctly. And once you do, it works. And so now if I do conda export again, you will now see it has the full environment path. You will also see pip is here, and there's also Python 3.13. So this one seems to have been a little bit misleading because it said the main one was 3.14. However, we can also see that we're getting 3.13. But also, I realized that the channel is actually from default, not conda forge likely. So if I do this, you now see on here channels that included conda-forge. And then, yes, you can upgrade that. Now if I do conda export 3.17, but we can also see now that it has multiple channels in there. Now, the other part of this that's going to be interesting and why I was saying we're going to make it reproducible is I can actually go in here and I can do conda export, and I can actually export this to a file, and we can call it like Bioinformagic python.yaml. And what this does is now I have a folder here, or a file I should say here, that's called bioinformagic python.yaml. And we'll have to see which one do I have. Vim yet? Yes, okay. Might be a little bit weird for people who haven't used Vim if you're used to, say, something like VS Code or something like that. I'll show you how to use that in the next video. But for now, just to kind of show, if I do Vim and I do bioinformagic.yaml, I can actually go through and edit it, and you can see that this is actually what's in my file. And then I don't have any changes, so I can just quit, and that's everything that's in that file. So with this, you can provide this YAML file to anyone you want, and you can remake a whole environment. So for instance, if I was to pass this along to a collaborator, they could remake this entire Python repo, Python environment that I created and reuse it for their own needs. And then I would know that they are using the exact same packages with, in fact, the same versions and everything, which helps to lock things down. So you don't have issues where, say, I'm using Python 3.13 and they're using, say, Python 3.7. And there's probably some dependencies issues. Certain code will not work the same because they have updates and stuff like that. And then with it, we can know that we're getting the same results. And if we're not getting the same results, that means it's something in our code, and we can help check one of those boxes off of we know we're using the same environment. So I will continue with the next video, but I think I will move us over to VS Code on the next one and show you that all of this integrates into VS Code as well, because I know that's a code editor that a lot of people use. If you have interest in learning about Vim and tmux and stuff like that, and doing more command line things, which is what this really is, even though it looks graphical, it's still based in a GUI for more or less of a thing. I'm happy to go into that. I can do a little video and do a little bit of exploration based on what people like. So until next time.